Alright, last but not least for this segment, suppose you wanted to find the field of a circular loop at a point R that is not directly above the center. You might as well choose your axis that R lies on the YZ plane at 0, YZ. The source point is R cosine phi hat or phi prime R sine phi prime 0, and phi prime runs from 0 to 2 pi. Set up the integral from which you could calculate bx, by, bz, and evaluate bx explicitly. This is going to turn into a mess, so hold on with me. All right, so we know that from this, we can use the Biot-Savart law, and we just need to find the parameters. So the script r vector, the separation vector, is negative r cosine phi. We just drop the primes for convenience. X hat, and then y minus r sine phi, y hat, and then plus z hat. Finding the magnitude of that, squaring it, gives us a cool thing of cancellation with the trig identities. And so script r squared is equal to r squared plus y squared plus z squared minus 2ry sine phi. Source coordinates are as such. And so therefore the dl prime is equal to negative r sine phi d phi x hat plus r cosine phi d phi y hat plus 0 z hat. Good to go there. Now we just need to take the determinant, or the cross product, which is the determinant. Move that through. We get something pretty simple there. Since we're only asked to evaluate bx explicitly, that's what we do, which it turns out to be 0 here, as you see. I'll let you look through the work real quick. The next part is the most important, and since sine of phi is equal to 0 at both limits, the y and z components are elliptic integrals and cannot be expressed in terms of elementary functions. So I'll list them below. But elliptic integrals in general are really messy, and you probably, if you're going to study this, you might want to see it more often, or go to something like a complex analysis. There's several types of integrals you're going to run into in physics, but be aware they do exist.